Hello students, in this video you will find acidity of a base. Previous video I have told you basicity of acid. First, what is acidity of a base? The number of replaceable hydroxyl ion per molecule of a base is called acidity of a base. Second way, you can define the number of hydroxyl ions produced by one molecule of a base on dissociation in molten state or in aqueous solution is called acidity of that base. Third way, number of hydrogen ion or hydronium ion of an acid required for complete neutralization or complete reaction of one molecule of a base is called acidity of that base. Now classification of base. Classification of base on the basis of acidity. Now here first, monoacidic base. Monoacidic base, a base which produces only one hydroxyl ion per molecule on dissociation or ionization in molten or aqueous solution form is called monoacidic base. Once again, a base or alkali which produces only one hydroxyl ion per molecule on dissociation or ionization in its aqueous solution is called monoacidic base. Next way you can say, if the number of hydrogen ion or hydronium ion required for complete reaction with one molecule of a base is called monoacidic base. Example, NaOH when dissolves in water produces sodium ion and hydroxyl ion. Potassium hydroxide dissolves in water produces potassium ion and only one hydroxyl ion as the negatively charged ion. A non-metallic example, ammonium hydroxide in its aqueous solution produces only one hydroxyl ion per molecule in its aqueous solution. Hence, these are monoacidic bases. Number 2, diacidic base. Diacidic base, a base which contain two replaceable hydroxyl ion per molecule is called diacidic base. Second way you can define, a base or alkali which produces two hydroxyl ion per molecule on dissociation or ionization in molten or aqueous solution form is called diacidic base. Third way, if the number of hydrogen ion or hydronium ion required for complete reaction with one molecule of a base is 2, then this is a diacidic base. Now see the example, barium hydroxide in aqueous solution produces 2 hydroxyl ion. Calcium hydroxide in aqueous solution produces 2 hydroxyl ion. This is a strong base, 2 hydroxyl ion. Then these are example of diacidic bases. Some are insoluble in water, that does not produce 2 hydroxyl ion, but it has 2 replaceable hydroxyl ion per molecule. Cupric hydroxide, 2 hydroxyl ions are there. Hence, these are insoluble base. They are not alkali, but they have 2 replaceable hydroxyl ion per molecule. Hence, these are diacidic base. Number 3, triacidic base. Triacidic base, a base which has 3 replaceable hydroxyl ion per molecule is called triacidic base. This definition is useful for any kind of base. It is not soluble in water, you can write this. But for soluble one, another definition. A base or alkali which produces 3 hydroxyl ion per molecule on complete dissociation or ionization in molten or aqueous solution form is called triacidic base. Or you can say the number of hydrogen ion, if the number of hydrogen ion or hydronium ion of an acid required for complete reaction or complete neutralization of one molecule of a base is 3, then the base is triacidic base. Now see the example, like FeOH whole 3, that is not soluble in water. It will not produce OH minus ion in aqueous solution, but it has 3 replaceable hydroxyl ion, hence this is a triacidic base. Then how you will show this? It requires 3 molecule of HCl, because here 3 OH is there to form FeCl3 plus 3H2O. This is a triacidic base because one molecule provides 3 OH minus, hence 3H plus is required for complete reaction to form water. Then here in this case 3 OH is there, 3H is there. Then for neutralizing 3 OH minus, 3H is needed. Then only it will form 3H2O. See, equation is balanced. 6 hydrogen, 3 oxygen in this case also. Now next is like that bismuth hydroxide is a triacidic base. Then these are some examples of triacidic bases. That's all for today. Again next class I will tell you. Thank you.